Hello Legacy Sabers, Marsh here. So today we're going to talk about how to graph hyperbolas at the origin. Again, you're going to want to find your conics foldable so that you can take the notes on this particular conic. So you want this foldable, and the tab that we're going to be filling out today is the hyperbolas tab. So go ahead and go find that tab here quick, and then you can be able to take some notes. So the first thing we need to talk about is the parts of a hyperbola. So we have this really lovely graph in our notes here, and there's some very important content that we need to talk about. So the first thing is the center. The center is the middle of the hyperbola, so in this case it is at the origin. And then we also have what's known as your vertices, vertex for one of them. The vertices are what cause these, I would say they're like a parabola looking like thing, but they would be the hyperbolas in our case. And then we also have a focus on each side that is in the middle of the hyperbolas. And then of course we have what's known as the asymptotes. We have seen asymptotes already in our studies in Enriched Algebra 2. However, these guys also have asymptotes. So what a hyperbola is the focus, the vertices is so far from the center, and then the focus is how far your graph is away from the center at all times. They're equidistant, kind of like how the ellipse had it. And the asymptote shows how far out the graph, the hyperbola, can actually extend, if that makes any sense, in our regard. Now, standard form of a hyperbola, there is an equation that we're going to have. So x squared over a squared minus y squared over b squared equals 1. And in our case, again, a and b also have designations. A is how far our vertices are from our center. And right here, this information right here, you're going to definitely want to take that information down because it's going to really help you later. So A is center to vertices. Your B value is how far your vertices are to the asymptote. So notice what that is. So A is here, B goes up to there. Takes a little bit of thinking as we're doing it, but B is your vertices to your asymptote. And you're probably thinking, well, Marsh, what about the focus? Well, our C value is our foci focus to the center. So we're going to have to watch for that each time. Now you're probably thinking, C's not in the equation, Marsh. How can I find the C value? Well, just like how ellipses had a formula to find C, so do the hyperbolas. I do want to point out, though, with the standard form of our hyperbola, notice there is a subtraction in the middle. That is what makes this different than an ellipse, because there's subtraction in the middle. So be careful with that. Our formula for the C to find the foci is c squared equals a squared plus b squared. So this is, in fact, the Pythagorean theorem. So here's how I keep this straight, because you're thinking, how am I going to make sure I keep these straight? Well, if the formula or the equation has a negative in it, that means I'm going to use the opposite. So the ellipse had a plus, we had to use a minus in our formula to find C. If the equation has a subtract in the inside, we're going to have to use a plus. We're going to use the opposite of each of them. So this formula right here is going to be our bread and butter to be able to find that C value of our graph. Now, just like an ellipse, we could also have a up and down or a left and right hyperbola opening up. So what we're going to see is which variable comes first in the equation. So if my equation has an x coming first, that means it's going to be a left and a right. And if it's up and down, you're going to have a y first. It does not matter what number is underneath lower. That is not, unfortunately, what tells us our values. It is only the information of what letter comes first in our equation. Now, again, let's remind ourselves, an asymptote. Asymptotes are just linear equations that our graph of a hyperbola will not cross over. So the graph's going to get closer and closer and closer to those asymptotes, but we're not going to actually cross them. So when we're drawing in our asymptotes, we're just going to have to keep in mind that when we draw our hyperbolas fully. All right, ladies and gents. So before we graph this equation here, there is some co-vertices right here. That is left over from the ellipses. So go ahead and do a quick on your foldable. Let that make sure it disappears quickly so we don't cover it here. I'm going to do a quick fix of that right now. Now I have fixed it. Let's go ahead and graph this equation. But first, I do notice this guy is not in standard form. He's not equal to 1. So I'm going to divide everybody by the number on the outside. So here, so I'm going to divide everybody by 36. Everybody, equal opportunity division. Can't just pick and choose who gets divided. Well, this doesn't simplify, right? So x squared over 36. 9 over 36. I wonder if that fraction can simplify. 9 divided by 36. That'd be 1/4, right? So y squared over 4, and that's equal to 1. Now, how do I know that this is a hyperbola, not an ellipse? It is a subtraction in the middle. That's what gives me the idea. Now, remember as well, with hyperbolas, it doesn't matter who has the bigger denominator, similar to an ellipse. You have to look at what letter comes first. That is different than the ellipse because this subtraction notates who's not the direction we're looking at. So since x is coming first, we have a left and right hyperbola. So it's going to be opening left and right on our graph. My center today will be 0, 0 because we're not moving. So I'm going to go right here. C, put a C there. My vertices, that is the number that's coming first. So it's A. So A is going to be 6. Square root of that. So I'm going to go 6 left and right. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So that's a vertice and a vertice. Okay. Let's label those down there. So 6, 0 and negative 6, 0. Now, we need to find our foci value. And actually, let's find our asymptotes first. So let's find those guys first. Remember, find the asymptote, you're going to use the b term. So it's going to be 2. So I need to go from my vertice, because remember what the b value was. It was vertice to the asymptote. So I'm going to go up 2 from the vertice. 1, 2. I'm going to do that on each way, up 2 and down 2. And then what I'm going to do is I'm going to connect through my center using a dashed line because it is a asymptote here. So there's 1. Doesn't have to be perfect, but you know, try your best. There we go. So those are my asymptotes. I need to find them here. So I need the equation of them. I need to write the equation of a line. Ooh, what do I need to write the equation of a line? I need the y-intercept or an ordered pair, right? And, well, I need to know the slope. So I need the slope, and there's 2 different lines, so I actually need the slope for 2 of them. So my slope, let's do this guy, is up 1, 2 over 1, 2, 3, 4, 5, 6. So y equals, well, rise over run, right? So 2/6, but that simplifies, right? So I'm going to change that to 1/3. And then, well, the y-intercept is 0, so I could just go 1/3 x. I could plus 0 if I wanted, but I'm just going to go 1/3 x. Let's look at the other equation. The other line, it goes down 2 over 1, 2, 3, 4, 5, 6. So the other equation is negative 2/6. So y equals negative 1/3 x. Those would be the 2 asymptotes that are present on this particular graph. Now, let's also find those foci. They should be past the vertex on each side. Well, c squared, we don't know that, right? A is 36. B is 4. So 36 plus 4, that is 40. So square root to find my C. Well, C has a value of, square root of 40 breaks down into 2 square roots of 10, roughly. So that's what C is. And 2 square roots of 10, that's got to be 6 and some change, probably. Probably more in 6.5 round. So I'm going to go 1, 2, 3, 4, 5, 6, and a little bit further. That is my focus. Here's my focus as well. Now, to draw in the actual hyperbola, I'm going to go from the vertice. I'm going to go really close to that. Let me change my color so it's easier for you guys to see it. Let's go purple. So I'm going to go from my vertice. I'm going to go really close to that asymptote on both sides. Something like that. So that graph's nice and pretty. And that is the end of this video. So when we get back to class, I plan on doing one more example with you guys so you can put it in your notes, and then you can ask me a couple of questions as well. And then we will move on next time to translated hyperbolas. I know, scary, right? But until then, I will see you later, Sabers.